So let's see what happens if we have a slight reduction in the R over V ratio. Okay, we come to something, a system which is called highly stratified estuary. And you think, oh, that looks very similar. Well, it does, but there's a significant difference. In this system, you have a substantial inflow of seawater through the bottom layer. A significant inflow of water. All of a sudden, for this system, you get a big inflow. There's also a slight difference in the salinity in the upper layer, and that might actually explain why you have this inflow. You can see the salinity. You come from the river of very low salinities, shown here as 0, and then as you move along, the salinity increases 10, 20, 30. Okay, so how can you explain this increase? There can't be any evaporation strong enough to do that within a time scale of a few hours. It's impossible. Okay? So the only mechanism that can explain such a salinity increase while you're moving downstream is if you add seawater salt from the bottom layer into the upper layer. And this is what happens here. And we'll see that more. I discuss this more on the next slide. Okay, so just see what happens if you now measure at these 4 different stations, 1, 2, 3, 4. You can see that the salinity increases as you go towards the ocean in the upper layer. There's seawater only in the bottom layer. Yeah, it's all at high salinities of marine environment, but there's this big substantial inflow, and this can actually bring new oxygen into the bottom layers of your estuary. Okay, it's a very significant difference. You can also see that you have the bottom layer is all marine. So if you have a freshwater species can only live upstream in the upper regions of your estuary. You have a very narrow transition zone. If you move along here, you're very on a relatively short scale. Okay, this is called the highly stratified estuary.